Just about any half-decent HMI out there gives you a way to store machine or process data into the long-term memory, so an operator can check it out later. On the CP600 range of panels, this functionality is called trend buffers, and here's how to get it running. As a way to display trend buffer data, we'll be using the history trend widget from the trends and charts group. But before getting into the widget settings, we first need to take care of a few things in the trend buffer configuration. Head over to the trends item in the project tree and open it. Create new trend and name it, let's say, temperatures. Now at the bottom of the screen, you can add the tags you want to include in the data login. So let's add supply and return water temperatures, ambient temperature, T1, T2, as well as fill up names and title fields for all items. Now let's see what are the available settings and how they work. The first parameter is number of samples. And here we need to talk about how the panel logs data in the first place. Essentially, it takes the value and metadata of each tag in your list, which takes exactly 9 bytes regardless of the data type, and pairs it with an 11-byte timestamp. It then saves the data into a trend buffer. That one piece of data is what we call a sample. Keep in mind that every panel has a specific amount of memory allocated to trend buffers. For the CP600 we're using, that's 200 megabytes. If you do the math and multiply the number of samples by the sample size, you'll see exactly how much memory is used. Panel Builder indicates it as a percentage at the top of the screen. How often the panel saves samples to the trend buffer is defined by the sampling time. For things like temperature, 5 seconds is usually plenty, since those values don't change that rapidly. In practical terms, when you combine 5 seconds sampling rate with this number of samples, the panel will hold 2 weeks worth of data. It's also worth noting that the sampling time doesn't have to be a fixed number. You can attach it to any tag and then control granularity of data in the trend buffer during runtime. You can even stop logging for a specific buffer entirely by setting this sampling time to 0. It could be a way to conserve trend buffer memory when process or machine is sitting idle. If you need even more flexibility, you can switch over to using a trigger. When you select a tag as a trigger, the panel stops watching the sampling time and instead records a sample whenever the trigger's value changes. You can use the trigger filter parameters as a deadband. This lets you decide exactly how significant a change needs to be before it triggers a new recording. The storage device setting determines where the buffer actually lives. You can keep it in the panel's internal memory or move it to removable storage like a USB stick or an SD card. Switching to an external card doesn't actually increase the size of the buffer. You're still working with the same memory limit regardless of where you save it. Now, what happens when we finally hit that maximum number of samples? You've got 2 ways to handle it. By default, the panel just clears out the oldest entries to make room for the new stuff. That's your standard first in, first out behavior, no real surprises here. But if that data is too important to lose, you can use the backup option. Just check the Save a Copy When Full box, select CSV, and then pick where you want that archive to go. Usually you'd point this toward your removable storage. You can fine-tune which texts have to be exported and how the CSV export file should be formatted. Once the buffer hits its limit, the panel automatically exports the backup and clears the buffer. Alright, the trend buffer is all set. Go ahead and save the project. You'll probably see a prompt warning you that the next download might wipe any existing data on the panel. Just hit confirm. Now we can head back to the history trend widget and start shaping the operator's experience. Set the page duration to 10 minutes and adjust the vertical axis to cover a range of 30 to 80 degrees. We can ditch the text title to save some space. Make the grid a darker gray and clean up the time format on the horizontal axis. While you're there, tweak the font color and size. Do the same for the vertical axis. You can remove the vertical text too, the grid lines alone will do the job. Finally, resize the widget so it fits the entire screen. Now for the most important part, getting those curves on the screen. Just like we did with the real-time trend, you would go to Curve 1, then Trend and select Trend. But notice that this is a bit different than before. Instead of linking directly to a tag, you're linking to the specific item we configured in the trend buffer. Let's start with the supply water temperature. Let's fire up the simulation and see how it works. You'll need to give it a moment for system to gather some samples. Yep, the curve is here. Now, the biggest difference from the real-time trend we used earlier is that historical values are kept even if we navigate away from the page with the trend widget, which is not the case for the real-time trend. Going back to our history trend, one thing you get right out of the box is time scrolling. In the simulator, you just click and drag the mouse. On the actual panel, you do the same with your finger. You'll notice that as you scroll sideways, the curve and the vertical axis markings move up and down as well. Sometimes it's what you want, but for this project, I'd much rather have the temperature range stay locked. Another thing you might notice is that we can't zoom in or out, and usually you would want to have this option in a runtime. Let's fix it. First, how do we deal with the graph's vertical sliding? If you head over to the white scale settings, you'll see that the minimum and maximum values are highlighted in yellow, which means those properties have a data link. The data link leads somewhere to the history trend widget's internals, but we don't really need to get into the weeds. The point is that if you want to keep vertical axis static, remove these data links. Make sure to do the same thing in the Curve 1 settings as well. Now let's tackle the zoom issue. To make this work, we're going to need a button. Go to Click Action and expand Trend Graph category. You'll see the bunch of actions available. It's worth taking a minute to look through them just to know what kind of tools you have at your disposal. Since we're here for the zoom, go ahead and select the Zoom In Trend action. Over on the right, you'll need to pick the name of the trend widget you want the button to control. You can find that under the ID property in the General group. It's always a good habit to give your widgets meaningful names. You'll see how much easier that makes your life later. Let me prettify the button a bit and add an icon to it. Now, since we have a zoom in function, we obviously need a way to zoom back out. Add another button with the zoom out trend action. And because it's easy to get lost when you start zooming in and out, we need a backup option, a zoom reset button. Okay, time to check it in the simulation. First, the scrolling. It still works perfectly along the time axis, but no matter how much I try to drag it vertically, the graph stays locked in place. Perfect. Now for the time scale. Zoom it out. Watch how the horizontal axis stretches over 8 hours now. Zoom in, and the whole graph fits within 1 minute window. Finally, reset brings us to where we started, at the default 10 minutes view. I actually lied to you before when I said that we couldn't zoom in and out. Pro panel we use in this project has a multi-touch screen, which means you can use pinch gesture to zoom in and out things like trend graphs. Nevertheless, you still need a button to reset, and I think that was a good exercise. Since we're dealing with a tightly interconnected system, it makes sense to have all those temperature values living on the same graph. Change number of curves to 4, set curve 2 as the return water temperature and give it green color. For curve 3 and 4, we'll map those T1 and T2, set points for the first two temperatures. Reduce their stroke width and use a less saturated blue and green. When you've got several curves packed into one graph, you might run into the situation where you need to toggle them on and off dynamically. So how do we do that? I'll start by adding a switch. It looks like a standard checkbox and toggles its state whenever it's clicked. Now, let's say we want to control the visibility of return temperature curve. Open up the Attach to dialog, but here's the trick. Instead of searching for a tag, switch to the Widget tab. You will see the list of all widgets residing on the current page. By the way, now you see why giving your widgets proper names is a good idea. Extend the historic trend widget, find curve 2, and select the visible property. Duplicate that checkbox and do the same for the T2 curve. And your checkboxes are directly toggling the visibility of the curves. Isn't it cool? This way you can link one widget's property to another without need of any external or internal tags. It was easy to add temperatures which lie in roughly the same range, but what do we do with something like ambient temperature, which spans from -15 to +15 degrees? Or even better example, what if we want to see discharge pressure on the same graph? Now we're not even talking about the same units anymore. Let's see what we can do. First things first, create another trend buffer for pressure values. Since pressure usually fluctuates a bit faster than temperature, we'll want a faster sampling interval. Add one more curve to the same historic trend widget, make it orange, and link to the pressure trend buffer item. Adjust the y-axis limits to range from 0 to 16 bar. And for the final piece, let's add the second scale. Hop back to Widgets Edit mode and add one more column to the left. Copy the existing scale and paste it to the new empty box. Change its min and max to 0 and 16 respectively, or better to 15 to keep the increments cleaner. Next, head into the column settings and reduce the width. Finally, I'll change the text color to orange so the operator can immediately tell that this scale belongs to the pressure curve. One quick check in simulation, and there it is. Now, imagine you're scrolling back to get a closer look to this specific time window. You can see tendencies and can roughly estimate the values, but sometimes it's not enough and you need to see the exact temperature or pressure. That's where the cursor functionality comes in. When you enable the cursor on the trend, it acts as a vertical prop or marker. Every curve on your graph has a cursor value property, which is essentially just the data point where the curve and the cursor intersect. Right, let's build something useful out of this. I'll start by tweaking the thickness and color. We'll need a button to show the cursor in the runtime. Head over to the available trend graph actions and look for Show Trend Cursor. We'll do the exact same thing for a second button to hide it. The only difference, the Show Cursor property is set to false. A similar approach applies to time navigation buttons, only this time I'll use Scroll Trend Cursor action with respective scroll direction. For the curve value, I'll drop a numeric field and link it to the cursor value property of curve 1. I could just leave it sitting statically below the graph, but let's make it a bit more intuitive. I'll move the numeric field over to the right edge and mark the vertical positions for the scales minimum and maximum. Then I'll use those coordinates to make the widget slide up and down vertically. We used this exact same trick in the last chapter to move a needle. Remember? Now we just repeat those same steps for curve 2, return temperature, and curve 5, discharge pressure. The logic is identical, but keep an eye on the min and max pressure values. If we're showing the exact curve values, we definitely need the exact cursor time as well. I'll clear out some space between the navigation buttons and drag in a time date field. To keep it clean, I'll change the format so it only displays the time, then resize it and give it the same cursor color. Finally, link the value to the cursor timestamp property. Now as operator scrolls through history, he doesn't just see the what, he also sees the exact when. Okay, we've added a lot of stuff on the screen, but half of it is only needed when the cursor is active. I'm going to make the show and hide buttons handle the visibility of all those related elements too. Add one more action to show cursor button. In group tag, find the action set bit and point it to the visibility property of the scroll left button. The hide button will do the opposite using reset bit action on the same property. Repeat the same logic for timestamp, scroll right button, and all that floating curves values. Finally, I'll set all those widgets and the cursor itself to be hidden by default. It's time to put it to the test. Hit the show button, and there it is. The timestamp appears right where we put it. Now scroll to the right and watch what happens when the cursor hits those curves. Cool! Numeric fields are sliding up and down as we move back and forth through time. From here on, I'd like to highlight some additional features which you might not necessarily use, but it's good to know they are there. The first one is manual trend backup. You don't actually have to wait for the trend buffer to fill up. Just add a button, go to Actions, and look for Dump Trend under the System group. Select the trend name and all other parameters, and you're all set. You can also purge trend data if you wish by using Delete Trend action. Dump operation, depending on the buffer size, could be quite resource heavy. You definitely don't want to double trigger it, or even worse, plug out the USB drive while the system is in the middle of writing. To keep things safe, we can use the disable property of that button. Open the Attach to dialog, but this time head over to the System tab. Here you will find number of tags which either reflect panel status or control it. Inside System tab, look for the Dump Information group and find the Dump Trend Status tag. The help system has a full breakdown of every state. A value of 1 means the operation has been triggered, but isn't finished yet. And that's exactly what we need for our safety interlock. Create a new formula, drop in a dump trend status tag and compare it against one. This way the button will stay inactive until dump operation is finished. You can also use these status values to trigger a success or error message. Okay, I promise this is the last one. While we usually think of viewing buffers in terms of lines and curves, it doesn't always have to be a graph. If you look at the widget gallery, you'll find the trend table widget, which does, well, what it says: present the buffer as a spreadsheet-style table. To be fair, scrolling through thousands of rows of cycling data isn't always the most practical way to spend an afternoon. But if you have event-triggered sampling, like recording a snapshot of equipment state, a table is actually a fantastic way to track those changes. Another non-obvious thing is that you can sample not only numeric data, but strings up to 8 byte long as well. Where might it be helpful? A customer showed me once a good use case in a crane application. He encoded state of a joystick controller into short string, and then logged each command crane operator produced. It basically worked as a black box flight recorder for machine commands. In our setup, we could encode pump states into string variables and then map them to an event-triggered buffer. Here's how it might look in the runtime. 6 minutes 59 seconds, pump 2 switched to auto. 7 minutes 21 seconds, pump 1 stopped and pump 2 started through a VSD. Alright, that's all for today. Be safe and I'll catch you in the next one.